Hello, and welcome to this video demonstration of improved out-of-sync project handling in IBM's Rational Team Concert version 6.01. This demonstration will show the Eclipse client, but improved out-of-sync handling is also present in the Visual Studio client and the command line interface. An out-of-sync condition occurs when the state of the local sandbox and the repository workspace on the server diverge. This is an uncommon condition, but can occur in various situations, such as network or workstation failures during load, accept, or check-in operations. Once a project is out of sync, it must be resynchronized before further SCM operations can be performed. In previous versions of RTC, this could prove troublesome, as the recovery procedure required the user to manually save all uncommitted local changes, reload the project, and then manually restore the local changes. Starting with version 6.01, RTC automatically preserves local changes when reloading out-of-sync projects. Conflicts are merged automatically where possible, and conflict records are shown where user intervention is required. One common but discouraged workflow that results in an out-of-sync project is modifying the same repository workspace in separate sandboxes. We will use this scenario to look at the most common types of changes and conflicts you are likely to encounter in an out-of-sync situation. On the screen, you see that we have two Eclipse clients. Both clients have the same repository workspace uploaded, WS1. Each client, however, is using its own sandbox. To save time, I have already edited files on both clients to produce the out-of-sync situation. Let's take a look at the different kinds of changes that have been made. The file autoresolvableconflict.txt contains non-conflicting content changes and non-conflicting property changes. Which will be automatically merged during the reload. The file binary.exe also contains non-conflicting content changes, but because the file type is binary, RTC will not automatically merge the content. Merging binary files is seldom a good idea. Next, we have a series of text files with conflicting changes, which we will use to demonstrate the various ways the user can choose to resolve conflicts: resolving with mine, resolving with proposed, and resolving with merged. Local change only.txt is an example of the most common kind of change you are likely to encounter, a file that is changed only locally on the out-of-sync client. You can see that there is no unresolved change for it on the right-hand side. And finally, we have two new files, one created on the left and one created on the right. Now that the setup is complete, we are ready to start. Let's check our unresolved sandbox changes in the right side Eclipse into the repository workspace. The check-in proceeds normally, since the state of the repository workspace was consistent with the sandbox. No other client has modified the repository workspace. The changes on the left are unresolved, meaning that they exist only in that Eclipse's sandbox. We can give the change set a comment, and we are done with this Eclipse client, and we can focus on the left-hand client. This Eclipse sandbox is now out of sync with the repository workspace. There is no indication that this is the case, since this client has not contacted the server yet. Let's try and check in the unresolved changes from this client. Here we see the warning that the project in our local sandbox is out of sync with the repository workspace on the server. We will follow the recommendation of the error message and cancel the check-in. And reload the out-of-sync projects by clicking on the Reload These Projects link. The Load Repository wizard opens and the Reload Out-of-Sync Projects option is already selected. By default, local changes are preserved, which is what you want 99% of the time. If you did want to discard your local changes, there is an option on the next page. Since we do want to preserve our local changes in this demonstration, we will leave this option unchecked and click Finish to perform the load. Once the load is completed, you will see a collection of preserved, unresolved local changes, as well as a collection of conflict markers for local changes that conflict with repository workspace changes. Not all unresolved changes have a corresponding conflict, since there was either no conflict between the local change and the repository workspace, or the change could be automatically merged. Let's take a detailed look at the changes, beginning with the non-conflicting and auto-merged results. The new file, newOnWrite.txt, created on the right-hand eclipse, has been loaded into our sandbox. You will notice that the content matches what we created on the right-hand side, and you will also notice there is no unresolved change for this file, since this is a file that was loaded from the repository workspace. The file newOnLeft.txt created in this client is still present as an outgoing change and has the expected contents. AutoResolvable conflict.txt has the property changes made on both the left and the right-hand side, as well as the content changes made on both the left and the right-hand side. These changes have been automatically merged since they were disjoint and non-conflicting. LocalChangesOnly.txt has preserved the changes we made locally in this client. You will also notice, as expected, that there were no conflict records for any of these files. Before continuing, we will check these changes in to reduce clutter in the Pending Changes view. Now, let's examine the conflicts. We can double-click the conflict record to open a conflict compare editor. Let's start with conflictingchanges.txt. Opening the ancestor pane clearly shows that the same line has been edited locally and remotely. In this example, let's assume that both changes are appropriate. We can choose to copy the current change from right to left. We can also see that there's a conflict in the properties. But let's assume the property value changed on left is the one we want to keep. So there's nothing to do for the property change. With the content changes made, we are done manually merging this file. Clicking the Resolve as Merged button will save the changes and remove the conflict marker. We can open the outgoing unresolved change to confirm that the file content is what we intended. Opening KeepProposed.txt shows the same type of three-way conflict. Let's assume we want to keep the proposed version, that is, the remote version checked into the repository workspace from the right-hand client. We simply choose Resolve with Proposed from the context menu. which will undo the local change. We can see the unresolved change and corresponding conflict record for keep proposed has been removed. And the local contents of the file reflect the version from the repository workspace. Opening the keepmine.txt conflict shows the same type of change again. But this time, we want to keep the local copy. Select Resolve with Mine from the context menu. The conflict marker is removed. The unresolved change remains and contains the local content. Resolve with Mine and Resolve with Merged are very similar actions. Both will remove the conflict marker to indicate that your current local unresolved change is the one to be checked in. The only difference is that Resolve with Merged will warn you if you have made no merging edits to your local content. This is a reminder that although you've indicated an intention to merge the remote and local contents, you have performed no merging edits and are simply taking the local content in preference to the remote. Finally, we have the binary.exe file. Although we know the contents of this file could have been auto-merged, they were not, since auto-merging binary files is not a good idea. Generally, you will need to determine which binary file is appropriate and either resolve with mine or resolve with proposed. Now that we have dealt with all the conflict markers, our sandbox and repository workspace are in sync, and we can continue working normally, including checking in our merged unresolved changes. This concludes the demonstration of improved out-of-sync handling. Thank you for watching, and we hope you find this and the other new features of RTC 601 useful and easy to use.